Let us solve a question that was asked in JM Economics paper of 2023. The question is, if x star y star is the optimal solution of this problem, that is, maximize f of xy is equal to 100 minus e to the power minus x minus e to the power negative y, subject to the constraint e times x plus y is equal to e divided by e minus 1, where x and y are both positive quantities, then under root of y star upon x star is equal to, we need to find out that very thing. Okay, so what we are being given, we are being given the the objective function. That means we want to maximize our objective function, that is f of xy is equal to 100 minus e to the power minus x minus e to the power minus y. Okay, and we have the constraint here, like we have the budget constraint in economics, that is e to the power x, sorry, e times x. E is the exponential function here, okay, plus y should be equal to e upon e minus 1. Okay, first thing is, what will we do? We will set this constraint equal to 0, that is, we will form the Lagrange's function. The first step is to set this constraint equal to 0, that is, e divided by e minus 1. To this we subtract ex minus y, and we set it equal to 0. And after that, what we do, we multiply this resulting constant with lambda. After that, we form the Lagrange's function such that we add the given what we call here objective function, which is 100 minus e to the power minus x minus e to the power minus y. To this we add this resulting constant, that is lambda bracket e divided by e minus 1 minus ex minus y. This is our Lagrange's function. Now to find the optimal values of x and y, what we do, we partially differentiate this Lagrange's function first with respect to x and set it equal to 0, and then with respect to y and set it equal to 0, and solve them simultaneously. Let's take the partial derivative of this function with respect to x. L subscript x means the partial derivative of this Lagrange's function with respect to x. Okay, so here we have the function e minus e to the power minus x. Its derivative with respect to x will be minus e raised power minus x times minus 1. Okay, this function and the coefficient of this exponent here, that means the derivative of x is here 1, so we write this here. Okay, if we have e to the power minus nx, its derivative is simply e to the power nx, that is minus nx, times the derivative of x, which is here 1, so we are left with minus n. I am just following this very procedure here. So this becomes here minus into minus is plus, we will get e to the power minus x. So derivative of constant is 0, derivative of this term came out to be e to the power minus x, e to the power minus x. Since we are taking partial derivative with respect to x, derivative of this will be also equal to 0. Here no x is involved. Here we have the x. Derivative of x here will be 1, so we will be left with minus e, and we set it equal to 0. This is the partial derivative of Lagrange's function with respect to x. Symmetrically, we take the partial derivative with respect to y. Okay, so here we have minus e to the power minus y. Its derivative with respect to y will be equal to minus e raised power minus y. Derivative of y is 1, so we multiply it with minus 1. So minus into minus is plus. Again we get e to the power minus y. So we get e to the power minus y. Okay, here we have y in this last term, so its derivative will be here 1, so we will be left with minus 1, and we set it equal to 0. After that, or let's solve them here first. Okay, we can write it in this fashion: e to the power minus x is equal to e, if I transpose it here, and here it implies e to the power minus y is equal to 1. Let us say this is equation first, this is equation second. After that, what we do, we divide equation first with equation second. That means 1 divided by 2 is equal to, so we have e to the power minus x divided by e to the power minus y. It should be equal to e upon 1 is equal to e. Or we can write it in this fashion. Let's transpose numerator to denominator and denominator to numerator. So exponent sign gets changed. So we will get e to the power y if I transpose it to the numerator, and if I transpose this numerator, its exponent sign will get changed and it will become e to the power x should be equal to e. That means we can write this expression in this form, that is e to the power y minus x is equal to e to the power 1. Okay, since we have the same base here, we can equate the exponents. That implies y minus x should be equal to 1, which implies x plus 1 is equal to y here, x plus, or we can write it in this fashion, that is our x is equal to y minus 1. We plug the value of x is equal to y minus 1 into the constant function. So we have e in place of y, in place of x we have y minus 1 plus we have y should be equal to e upon e minus 1, or let's multiply here, we will get ey minus e plus y is equal to e upon e minus 1. So we have ey plus ey plus y is equal to e divided by e minus 1. Transposing this e, it will get added. Or we can take y common and we will be left with e plus 1 on the, or on LHS here. Let's multiply. So we have e plus, then we have e square, e plus e square minus e divided by e minus 1. So e and e gets cancelled. Let me see if I have the space to write the other stuff here. Okay, I am doing it by step. You can do it pretty fast there in examination. Rather you would have done it pretty faster. So here we get e square upon e minus 1, e square divided by e minus 1. If I transpose it, it will get multiplied. So we will get 1 divided by e plus 1 when I transpose it this here. So it becomes e square divided by e minus 1 e plus 1. So that is a square minus b square, the formula. So we will get e square minus 1. So this is the value of y. So y is equal to this. Now what will be the value of x, since we know x is equal to y minus 1. So this is our y, that is e square divided by e square minus 1. To this we subtract 1, which gives us x will be equal to so here we have e square, then multiplying minus e square, minus into minus is plus 1 divided by e square minus 1. So e square gets cancelled. We get 1 divided by e square minus 1. We got the value of x star and y star. Let us say this is our y star, which is equal to this stuff, and this is our x star, which is equal to this stuff. But we need to find out under root of y star upon x star. Okay, so let me see if I can write it here. So our y star upon x star will be equal to, so y star we got it equal to e square divided by e square minus 1. To this we divide x star, which is 1 divided by e square minus 1, which implies our y star upon x star will be equal to e square divided by e square minus 1. Transposing this, it will get multiplied and reciprocated. So e square minus 1 divided by 1. This and this gets cancelled. That means our y star upon x star came out to be e square. But we need to find out under root of y star. Okay. So we have y star upon x star. Since we want to find the under root, so so it is equal to e square here. Since we want to find under root, let us put under root here. Then we have to put under root sign here also. So square and root gets cancelled. That means under root y star upon x star, okay, is equal to E, and we know the value of E is 2.718, something like this, 2.718. That means since we have to take two decimal places, we can write it as 2.72. 2.72 will be the answer.